Thanks again, Alistair, and welcome everyone from all across the country. I'm really looking forward to presenting Bendigo GovHub Galkangu, as it's now called, on behalf of the Lyons team, as well as today here with Danny and Michael. And we'll speak to many of the challenges that the project very successfully overcame to create this fantastic project in the heart of Bendigo. We've been on this journey on the design of GovHub for about 6 years. We were successful in securing the project in a national design competition that was initiated by our clients, Development Victoria. And the GovHubs are part of a series of projects by the State Government of Victoria. One's already been built in Ballarat, one in Morwell, and the final one is the one that we were lucky enough to be part of, the Bendigo GovHub. It's part of a project of strengthening investment in in regional cities, relocating some government departments into those regional cities, but also building a culture of collaboration between local and state government in these projects. That they're essentially office spaces, as well as having public interface functions. In our project, there's Vic Roads, Department of Transport, Department of Parks, and the City of Greater Bendigo. And the project brings together all of these disparate organisations into this one building. The other really key part and driver of the project was our engagement at all stages with Dja Dja Wurrung, who are the traditional owners of the lands around Bendigo. Members of their community had a really important impact on all phases of the project, on the briefing, on the procurement of the project, as well as more directly contributing to the design of some elements such as artworks that are embedded in the project. And they'll have an ongoing role in being part of this project. The project is located in the very heart of Bendigo. For those who are familiar with Bendigo, or maybe not, Bendigo was a metropolis at the time of the gold rush in the 19th century. It was built in the model of a very classical European city, and the site that we're on is Littleton Terrace. It's a curved European-style boulevard, and our project actually occupies a whole city block, which was previously occupied by a number of different buildings from different eras. And the project consolidated all of these separate titles and blocks into one unified GovHub site right here in the centre of town. These are some of our earlier design development stage renders of the project, showing it in the context of the civic gardens that are opposite our park, as well as the town hall. So we had this really great location in the city within to make this important public project, but we want to make some very direct connections between our project and the city around us. And these diagrams show some of the ways in which we did that. First, we want to fill out the whole site, similar to how other parts of Bendigo are built right to the street edge, but that then set us the challenge of building to a curved street frontage, and you'll see how we dealt with further on in the presentation. We wanted to draw in some of the elements of the public spaces, such as the park and the forecourt, into our project to make a welcoming public plaza. And we also wanted to use this idea of moulding or pressing in some elements of the surrounding buildings, such as the library, the town hall, and the old Haymarket, pressing them into our building to make these small cutouts here, to make it look as if this building's been maybe been here longer than it actually seems as a contemporary building. Again, this is one of our design development renders at the point at which Icon Fairbrother came on to deliver the project, showing this curved street frontage and what we call these cutouts, where the landscape and the plaza pushes itself into the form of the building. This image here shows that we were able to achieve exactly what we were after, and using timber was a key part of achieving that geometry and all the other aspirations for the project, which included, for instance, keeping this existing lemon-scented gum that's on another corner of the site, that now the whole building folds around and creates this fantastic meeting room, as well as great advantages into the workplace. And finally, as part of the overview, the building is a very large building for up to 1,000 staff. It has 2 courtyards in the heart of it, shown here in this plan. And in the middle, there is a central staff hub space that all of the staff have access to for their social gatherings and just for your lunches and teas and coffees. That's this space here. And adjacent to the staff hub are these two great landscape courtyards which terrace through the building and bring light and views deep into the heart of the project. At its core, the project is a workplace, and the whole plan has been designed as two wings, a north wing and a south wing, connected by the staff hub, and at the east and the west. So it's a flexible and open plan workplace, allowing a lot of flexibility for some tenants to occupy an entire floor, as well as on other floors where it's broken up into separate tenants. There are parts of the building which are more publicly accessible, such as this large meeting room and this stair, whereas the rest of this workplace is entirely for staff to move through, especially using the staff hub and the two courtyards. One of the key decisions in the project, looking back, was the very early decision by Development Victoria to instruct us to adopt a timber structure which set in train all of the design and engineering and collaboration, which led to the successful outcome. It forced us to ensure that we were documenting everything in 3D. And for those of you who are familiar with timber construction, what you see is what you get. You are going to be seeing every conduit, cable, light fixture, other fixings, and we had to make sure that our documentation reflected as much of this as possible, so that we could be comfortable with the design outcome, as well as be able to present to our clients what the look and feel of the project will be like. These are some of our views from our documentation, which we undertook in Revit, which also shows that the project was actually a hybrid mass timber and concrete structure. There is a concrete structure on the ground floor. There are 3 concrete cores, as well as a car park. It's 2 levels of an inclined car park that's on the back half of the site. So the project is about 2/3 mass timber in terms of its structure and 1/3 concrete, which is probably a trend which will continue into the future as mass timber comes into the industry. Again, we also had to have very clear documentation of our ceiling plans, of our floor plans, even our below underfloor air distribution floor plans, to show the extent of all of the timber framing, all of the CLT, as well as, importantly for us, to document the visual requirements for the connections between the timber. As you've seen from the plans and from the renders, we did create those complex cutouts to bring light and views into the project and to make those very direct connections between the town hall and the civic gardens. But what that meant is we were forcing the timber to adopt geometries that are not typical of the system, such as these curved and angled geometries. So we created these drawings here, a few pages of them showing how we think these joints will come together. And then we worked very closely with ASH and with Fairbrother to develop these in much greater detail. The other fantastic thing about using timber is the precision of it, which I'm sure Michael and Danny will speak to. But it is quite incredible how these materials come together with 1 or 2 or 3 millimeter tolerances, but that then creates its own challenges in terms of interfacing with concrete or steel, which, as we all know, has different tolerances and deflections as well. This is in the middle of construction shot, showing some of the facade going up, and showing one of these cutouts here facing this main boulevard of Littleton Terrace. And these next couple of images show how some of that curved geometry was created in the project through faceting the beams here, faceting these mass timber beams, as well as faceting the edges of the CLT, and then the facade which clipped onto that provided the next layer of detail, also faceting to make those cutout shapes, but also afford these great views looking into and through the project and embracing this existing tree as well. In some areas of the project, the connections were quite challenging, and one of our key lessons learned is probably reflecting on the degree to which fire engineering needs to be used to work for all the different connection types. There's almost never enough engineering which you can do on a project. There are obviously always limits on that, but we think it is a key consideration when you do start to push the material in terms of its geometry and where the connections are exposed, that there was a very close collaboration with the engineering and building teams as well. And this is a view on the forecourt of the project. And then these next few images show, again, more in the middle of construction process. Here's our design team walking through the project, showing the timber just after it's been propped up. This is the CLT floor, which isn't exposed, but we do see the underside of it. One of the interesting observations that a colleague made was looking at this element here. They asked if it was a void. It's actually a riser. So we reckon it's the best framed, most beautiful mechanical duct riser going around. And that was in part a consequence of that when you do use timber, you want to use it in a consistent fashion. You want to minimize where you introduce other materials, such as steel or concrete, minimize the connection, those different connections, and use timber as much as possible, even in moments potentially such as this, to make these timber framed riser ducts. But the outcome of all of this is a workplace that, again, is very contemporary in its nature, biophilic in the sense that there's a lot of exposed timber here with the beams and the columns, and about 50% of the CLT ceilings. There's a lot of natural light coming in through the curtain walls on all four sides of the building. And again, we were very confident in going from the design views at 50% DD to what's being delivered by Fairbrother at the end of the project, which is really what we were expecting in terms of the project. Another key negotiation early in the design phase was around the different combinations of timber beam sizes, and whether we would use just primary beams, or we would whether use secondary beams, whether the services would be on the ceiling or in the floor. And obviously these sorts of negotiations are custom to every project in terms of its needs, but the key driver for us here was to maximise the exposure of the timber in the workplace levels. And Arup, who led all of the engineering here, were really instrumental in working through these different options and getting us to a point where we could go from the standard model of services in the ceiling to services in the underfloor, where again we had all the beams and columns visible and about 50% of the CLT visible on the ceiling, with the balance of it being fire-rated plasterboard as well as acoustic panels for those workplace areas. And this was that sort of last option. The other restriction that we set ourselves to make construction hopefully a little bit easier was not to have any penetrations in the beams. So we wanted to keep all the sprinklers and the lights within these zones here or in the underfloor, and not to have any penetrations through the beams here, which would have created other complications for coordination with services. Again, a view of the workplace as designed and then as delivered in the real project, which is looking great. And this is a view looking out to one of the courtyards. With the timber, it was also a key part of the interior materials palette. It does create a fantastic neutral and warm backdrop, but we also wanted to create a narrative that was connected to the forests around Bendigo. So each of the levels is color-coded with a different idea, either about the forest floor, about the iron bark of the trees, or about the tree canopy. So we use the structural mass timber as a background, and on top of that we use different color carpets, different color furnishings to identify each of the levels and create a very local narrative throughout the project. And here you can see another level up on level 3 using this ironbark themed color scheme. There are areas where we would have loved to have done a little bit more timber, such as this stair, the main public stair that's on the corner of the building, but it is all clad in timber. It does look great. Maybe on the next project, we can also push for timber stairs, but we also wanted to ensure that all parts of the project that weren't the concrete did maintain the same look and feel and be a really warm timbered space for both the public and for the staff to use. So finally, as my quick reflection on the project and some lessons learned, using mass timber construction, it's a really important step change in the construction industry changing and going to more sustainable forms of construction. And I don't think we should use to take but also how exciting that also is to be part of. Using the mass timber for us also connected into other bigger design narratives around engaging with local Indigenous culture, around the well-being of the workplace, and talking about innovation within making this some project. So it's not just timber, mass timber by itself, it's part of a larger narrative that fits into about creating a contemporary as well as locally connected project. The collaboration between architects, engineers, industry and builders is really critical. And another key step was having an ECI process where industry, ASH, came involved into the project just after the 50% design development stage. So having their input very early on really helped the project. Also, as I've mentioned, there's no hiding. Everything that you see in a mass timber building is going to be visible, so you have to be comfortable with how those connections work, but also how all the different services work as well. And we're able to, I think, successfully work that into the aesthetic of the project. And finally, this is a relatively new material and construction system that's really exciting. There are all sorts of new forms and ideas which can be made with it, often rectilinear, but there's also a lot of other forms and ways to use the material to create fantastic new projects all around the country. So I encourage you all to, get involved with mass timber on your next project. Thanks, Alistair. I'll hand over to Danny.
Thanks, Adam. That was fantastic. Yep, Danny, if you want to fire up your screen. And people online, please put some questions in the Q&A box if you'd like to ask some questions of Adam and the other speakers. Over to you, Danny.
Well, thanks, Alistair, and thanks, Adam, for that presentation as well. So I'm Danny, here to present the manufacturer's perspective of the project. So this was a great project for us to be a part of, and there's a first major works for ASH, but also a prime example of local mass timber suppliers in action with Xlam. So today I'll just be running through who ASH is, what some of the challenges in the project were, and what some of the lessons learned. So for a bit of background, Masslam is one of many different manufacturing products, allowing ASH to lean on some of the best people and infrastructure in the timber industry. In particular, the decades of finger joining and glue laminating experience was essential in producing almost 1,000 cubic meters of GLT required for this project. So just a few listing of some of the other products that ASH creates. So this is a photo of the Hayfield site. It's about 2 hours east of Melbourne, which employs around 200 people. And this is the setting for all the components that were produced for the project. We've also got our own green mill down the road and now have a sawmill in Tasmania, which keeps our 9 manufacturing lines busy. So the Masslam line highlighted here is where all of our mass timber is finger jointed, pressed, planed, CNC'd, finished, pre-attached and wrapped and packed ready for delivery. At the center of this line is our Bendigo K2I CNC machine. We've also got a secondary CNC machine available for smaller sections and a third one to be commissioned in March. So the Masslam line is unique in its ability to take individual sticks of timber and finger joint, press, plane and CNC in one complete line. So basically up here, you've got individual sticks coming in, similar to what you'd have for your framing timber, coming through finger joining press line and then into the CNC without anyone touching it in between. So this is the machine that produced the 748 individual GLT components to the manufacturing model. So going through the design process, this is one of ASH's first mass timber projects and largest to date. So the design process was completed by Xlam, with ASH assisting with the design for the GLT components. So Xlam and ASH worked collaboratively under an early supplier agreement to assist the consultants with timber connections that achieved the 90-minute FRL through a sacrificial chart layout. Early involvement identified potential risks in the design by evaluating each node point on structural performance, aesthetics, and the speed of install. So that's the node points you would have seen previously in Adam's presentation. So the first project-specific challenge was with the geometric complexity of the facade. So as Adam pointed out, a fantastic look for it, but as you can probably see here, all of these different connections are all unique. So each of those requires a different connection, different CNC, different fasteners, and then a look at how that all works in a fire rating system. So being a manufacturing line, modular construction is key for us, as it's easier to replicate the same component rather than produce unique parts. Basically the same concept as why an IKEA chair will be significantly cheaper than custom built furniture. So for us, this presented challenges with subtle differences between the thousands of steel and GLT pieces, which required in-depth QC offsite at Hayfield and also at Xlam's Wodonga site and on-site in Bendigo. So to look at how we sort of counteracted this, we looked to standardize aspects of the angled facade line. So we developed a series of plywood templates and tools to quickly check and pre-attach standard plates to unique connections, removing that complexity from the on-site. So the result here is connections that are all hidden. So that works on the aesthetic part of it, but it also works from a fire perspective, hiding all of those steel components beneath a sacrificial char layer. Second challenge was common to most projects at the time in the pandemic. So steel costs increased 40%. So an accelerated design program with early contractor involvement allowed us to procure components early with a fabricator in Hayfield. Fire testing was required to be organized remotely and all components coordinated for assembly at ASH before delivery to Warrington. Fortunately, due to both Xlam and ASH's manufacturing in regional areas only a few hours from site, the project delivery was not held up by international shipping concerns, allowing the design to continue in parallel without a lag from approved shop drawings to a finished pre-attached component arriving on site. At an early stage, fasteners procured from overseas were identified as a potential risk, but with early involvement, prototyping, and 3D modeling, these could be ordered with certainty to avoid getting lost on any Panama-bound boats. So in regards to prototyping, this was one of our first projects of this magnitude, and we really wanted to just test out our processes at scale to see if they were efficient. So to ensure each connection could be CNC'd and installed, ASH created a prototype of the typical connections to evaluate the smaller details of each type. This allowed small adjustments to be made in terms of tolerances and install before running on site where the stakes are much higher. Good example of this was the nicknamed reverse L connection. So that's this one here, which is the primary beam to column connection. By 3D modeling and prototyping the connections, we found that the screw layout didn't allow tooling to be able to access the area between the fins in here. And a slight change to the radius of slots would allow our CNC machine to cut in one pass. These seem like minor things, but brought up over the many, many different connection node points, there's 10 to 15 minutes to be saved to each part, which adds up to a lot over the whole project when you've got 750 parts. So this allowed us to make considerable savings in manufacture time, but also allowed the program to be accelerated with a second tower crane. To do all this, we use a combination of CNC and CAM. So with hundreds of tools available and the variables quickly climb for projects of this complexity, with many components containing 300 plus individual operations, each to a plus or minus mil tolerance. So this becomes of particular importance when it comes to interfacing with other materials such as steel and concrete, which have much larger tolerances on site. The timber side of it still needs to be accurate to work with the dowels and the screws, but to the steel and concrete side, it needs to still have the flexibility to be able to work on site. So the CAM allowed us to simulate the connections on the machine to see what was possible and where it could be improved. To remove further risk from the manufacturing program, ASH and Xlam pushed for a geometry freeze, effectively locking in all the CLT and GLT components, allowing for press manufacture to continue in parallel to detailed design for CNC and connections. This is helped by Lyons working in 3D as well as the two fabricators, ASH and Xlam, that we could coordinate and have a look at all of these in-depth connections. So to give you an idea of scale, on the left-hand side here, you've got approximately 10% of the total volume that was pressed. Each of these stacks is 4 meters high. all components, either pressed or fully packed and wrapped, ready for site delivery, like on the right, could be stored under cover at ASH's Hayfield facility. Complexity of connections was identified early as a potential pinch point to speed of install, with lift time the key criteria. So taking these connections off-site as much as possible allowed components to be ready to lift on site, and repetitive tasks such as the 40+ dowel pins or screws per connection to be done in a controlled factory environment. So it stopped the delay between lifts and also produce high quality with these being able to be controlled a little bit in the factory. So this pre-attachment required increased forward planning in terms of component delivery and sequence. So one of the advantages of local supply components were they're able to be manufactured just in time and held in undercover storage with flexibility and truck loading, allowing for the unforeseen delays on site due to weather and other trades. Unloading of trucks without demurrage delays did prove difficult, and we have since utilized pre-slinging and column stillages to reduce the unloading time, and also the number of lifts required to take components off the truck and into the required areas. So looking back for us on some of the lessons learned from our first major project, in terms of design, we've since tripled the Masslam design team to be able to take on all mass timber projects in-house at ASH, which really just allows us to get the most manufacturing efficiencies, but also speed of install and allowing for modular design. In terms of detailing, we've taken that simple detailing is often better, with some lessons learned on the behavior of our timber and to utilize material properties like our increased perpendicular to grain bearing, and to center around simple bearing type connections or even continuous beams to take out some of the complexity. Around milestones, we've looked to engage and educate early with consultants about the mass timber design process to understand how approval timelines work and how they interact with production. And then finally, transport, as I've mentioned, providing easy to install options straight off the truck to reduce that crane time. So thanks, Alistair and team, for presenting, and yeah, feel free to follow me up with any questions about this project or mass timber in general.
Thanks, Danny. That was great. If you just want to unshare your screen. And Michael.
Thanks, Alistair. Thanks, Adam and Danny. Great to relive the journey of Bendigo GovHub. So a little bit about myself. So I've been with Icon for 4 years, doing various commercial jobs with Icon, and then obviously came upon Bendigo GovHub and teamed up with the Fairbrother team who are head office in Bendigo, which was great. So a great joint venture with the local builder there and Icon taking on this great task. So I'm going to go through today just from a builder's perspective, the initial challenges when we onboarded the project, the key parties in the timber design process, which obviously Adam and Danny touched upon, the design process to take obviously the timber structure, but the concrete structure, facade, services along the journey, and what the design considerations were. And obviously some install considerations from a timber structure perspective that we developed along the way. And then I'll wrap it up with, I guess, our opportunities and lessons learned that we developed through the journey with the team. And I'll have a little sort of 1 minute, 1.5 minute video of the time lapse of the structure going up. So that's what I'll be discussing. So this project at the time sort of kicked off end of 2020, and we know how turbulent 2020 was with the pandemic. So it was a nice, meaty, complicated project from a timber perspective, but also had a lot of intricacies that Adam sort of touched upon with design intent. And it was obviously one of the biggest mass timber projects in the Southern Hemisphere. Well, it was the biggest at the time, with, you know, those sort of CLT and GLT numbers that you see on the screen. It was as Adam touched upon, it was predominantly a concrete slab on ground, concrete cores, and then a concrete car park, but the rest, front of house, roof, was all timber with some lightweight steel for balconies, the feature stair, and roof plant up on the top there. So yeah, there was a lot of interfaces with timber, concrete, and steel, and then, you know, you throw in the facade and also the finishes internally. Yeah, it was a pretty complicated project, and when we picked it up at 50%, there was obviously a lot to unpack and really get into the detail of how we construct it. With the timber, we obviously had ASH and Xlam, as Danny touched upon, working together collaboratively, and together we combined our pool of fire test data on the timber structure. But obviously, as Adam and Danny alluded to, there are some complex geometries, some interfaces between timber, concrete, and steel that we had to work through, and I'll touch upon how we design develop that in a later slide. And then throw into the mix the challenges with, as Danny alluded to, with procurement, so fixing supplies. So we overcame a few challenges there by going local, which I'll touch upon later as well. And then there was a few Australia firsts with the use of HBX glue that was fire engineered into the job, and we made sure that we abided by that to make sure that we had a conforming design. So they were some of the initial challenges that we, I guess, had to unpack when we picked up the job. And then the key parties that we got novated to us at 50% when we won the job, we had obviously Lyons that Adam represented, ASH with Danny there, and then we had Arup for fire engineering and structural engineering, which was great because collaboratively, those parties, along with Xlam, we were a pretty tight group that we iterated each connection detail, and obviously all those parties there had to tick their box from their respective disciplines. So it was an iterative process with those parties working pretty tight knit. Xlam, as Danny said, we're engaged for shop drawing at both the CLT and GLT, but I think what Danny's process and Danny's smarts on manufacturing, that really informed the GLT process and how we, I guess, made it the most efficient without minimal wastage of GLT. So we really leaned on Xlam and ASH for their smarts, working collaboratively, and we've taken that partnership on our current jobs that we're working on timber, and I know they're working on future jobs and current jobs elsewhere as a collaborative unit. So that's great to see those smarts being combined. ASH, obviously we're engaged with obviously with the Masslam that we've I'll talk a bit about what we came up with on site for ASH and the fixings. And then we had other parties involved, which were Warrington Fire, which we had to basically fire test a few families of connections that we had a lack of fire test data on, and were a bit bespoke and novel. So our fire engineer identified them, and we put them in for fire testing. But we also got Warrington Fire to do an independent third-party review of our fire engineering report before it went to the FRB. So we had a bit of third-party review, which is always a great thing. And I can't forget Standstruct were also our timber installer on site. We brought them in nice and early as well, because obviously there's a bit of smarts around the logistics, transport, and how we the sequence of install. So Look, all parties that you see on the page were intermittently in. They were very, very involved with obviously the architectural intent, the structural robustness, fire performance, safety being paramount for install, and obviously transport and logistics. So just as a high level, the design sequence for the timber structure only, the sequence really involved locking in I like to say locking in the architects, but we can never really lock in the architects. But we did work with Adam and the team to get some certainty around the structural profile of GovHub, which then allowed us to activate the timber outlines, as Danny alluded to, particularly for the columns and the beams. We had a bit of flexibility with the CLT floor plates because that would come later, but definitely we worked in with locking those timber outlines for GLT. Once we locked in those timber outlines, we then started getting into the tranche one of connection details for GLT. So all those connection details we call typical are those, we call it the 80-20 rule, where 80% of the typical connections had fire testing associated with them, and we could use them confidently. The non-typical tranche two, they were the ones that we had to do a bit further work on. They were really the complex geometries, multiple beams hanging off a column, a bit of steel exposed. So we really spent a lot of time in tranche two, detailing and working through with the stakeholders how we promote, challenge and agree on those non-typical connections. And that sort of 80-20 rule activated a lot of early procurement of the typical connections, while it allowed us to go into detailing the non-typical. So that's where that's probably our process that we worked through, and then we started workshopping the CLT, which happened thereafter. So all in all, it took about 5 months to get from picking up the drawings to 90%, from 90% design to timber available on site. So that was first arrival of timber. I'm not going to go into too much detail, just conscious of time, but look, there was a significant amount of fire engineering involved, and we picked up the fire engineering brief and took it to fire engineering report. But obviously we had a lot of fire testing that needed to be accommodated requested by the fire engineer. One of the biggest performance solutions we had was the 120 FRL down to 90, which assisted with, as Danny alluded to, the charring layer on the GLT, and that really helped us with getting the fire engineering sorted out and the fire testing approved prior to inclusion with the FER. And as I said, the FER went to Warrington for a peer review, and then it got submitted to the FRV, which all in all, we tested about 6 connections. They all passed on the first attempt, which was great at Warrington. And then we submitted our FER to FRV, and that was, in close dialogue, approved successfully. So that was a great outcome for fire testing. Look, just some quick fixing selections and procurement comments. Obviously, Danny alluded to, we got impacted on some supply chain issues. And so we reached out to local suppliers of obviously the GLT fixings, which were done in-house at ASH's factory, but also the CLT to CLT fixing that you can see on the screen in plan. We made them locally, and we got a mixture of various fixings or fasteners from Spax, Rothablas and locals to really make sure that we had certainty in availability, because we didn't want any of our structure being held up by, steel plates or fasteners not being available. Some small detailing that obviously impacted time for installation. We had a little detail that you can see on the right in red. There was we work pretty closely with with Standstruct and ASH, and obviously the engineers, structural engineers, to get a little GLT connection detail that allowed us to basically get the beams hanging off the columns prior to them being fixed into place. And it basically allowed us to drop a beam into that little notch that you can see there, and position the column, position the beam, in place where it will be fixed eventually. So it minimized hook time, or crane, tower crane or mobile crane time. That little seating hook introduced, it basically avoided, from a safety perspective, the need to get in and, Standstruct getting in and potentially having their hands caught in whilst the GLT's on the hook. So there was just these nifty little details that we picked up along the way that meant more safe installation and quicker installation from a tower crane and hook time perspective. The CLT to CLT joints, we sought information from Standstruct on that shiplap detail that you can see on the screen there in section. And we obviously maximised our CLT that you can see in plan, the colourful rectangles, to the maximum size that spans beam to beam, and also took into account transportation limitations. So a lot of sort of smaller things that meant really efficient installation down the track. Again, there was a few little wins that we sort of implemented into our CLT and GLT transportation that just meant when we got to site, everything was fitted off, prefabbed. You lift it off the truck in the right location into the final location, and we utilised, I guess, multiple cranes given the expansive floor plate of the site. In summary, there was quite a bit of timber structure and associated fixings and stitch plates. That's just a little summation of what we had there on site. Some rates that we achieved. We got the structure completed in 87 working days, which was a massive effort. I think we lost about 16 days to inclement weather, but we averaged about 18 members on, I think the best was 37 in a day members, and we got an 18 average across the working days. So it was a huge effort to the front end planning and the team out on site. So there was a few, as Danny sort of showed you in geographically, we had supplies from New South Wales and obviously in Victoria, and look, we made it all work, and we installed most of the structure in pretty extreme weather. As some of you may or may not, Bendigo is fairly hot in summer and very cold in winter, but we made it work with the conditions that were presented to us. Opportunities going forward. Look, we really see, as I think Adam alluded to, I mean, timber's going places that we're very excited about here in Australia, and Icon Fairbrother chomping at the bit really to get more mass timber projects across the line and work with architects and engineers alike. And we see it as something that the industry is moving forward. Mass timber is going to be the concrete and steel brother and sister to those elements. Another big winner, which Danny alluded to, was fitting in the factory. We highly back that call, and we wouldn't do it any other way. We don't want to fit on site. There's enough complexity on site when things arrive. We want to make sure it's all done at the front end. And then look, I mean, Danny and Xlam and the team, they've obviously got the smarts in the model, and front end can plan everything down to the tolerances that are specified. And I think with Adam and Lyons and the structural engineers inputting into the model, we all have a live version of the model that we, as stated, we build it once, we design it once, and we build it once with timber. There's no real having to post-fix something or change something out on site, which was fantastic. And then the last one, I think coatings. We think from a builder's perspective, we obviously have coatings for the architectural finish, but we would like to see, I guess, coatings in future from the suppliers for waterproofing and fire protecting. If we can go down that avenue of, you know, pre-factory coatings with waterproofing and fire protection issue with those provisions in them, I think that would be a huge outcome. And then look, there was so many benefits for Bendigo, and you know, as Adam said, we're basically in the heart of the town. We're getting all the government and municipalities into one location in the heart of Bendigo. We've obviously used ASH and Xlam from an Australian supply point of view. We got local fabricators of stitch plates and fasteners mixing through that. It was a great outcome for the Icon Fairbrother team. And really, I'm just going to summarize it with a bit of a video. So it's a bit of a time lapse of the structure going up. So you can see the concrete's done. That's the back of house and the cores have stood up. And there's the car park there. And then you can see pretty quickly timber will activate from ground floor. There's no basement here. So you can see the concrete columns going up at the foreground there, and straight away the GLT beams go on. CLT level 1 goes up, and then GLT level 1 goes up. CLT, I can't keep up, it's going so quick, but yeah, that's basically the sequence. And we had 2 teams of CLT working. You can't really see it, but essentially that was the fly through. And there you can see the roof of the structure again in CLT. That red is a Proctor wrap that was left there in the permanent scenario, and that just provided a bit of waterproof and vapor permeability before the metal deck roof went on top. There's a bit of a drone fly through. I think that's east-west. And you can see our tower crane in the middle, where we've got the little courtyard, the concrete courtyard in the center there. And there's the core and the timber structure. There's a bird's eye view of the job. You can see the facade going up there. There's the steel balcony, and just like to end the presentation with a big thank you. And look, the project couldn't be done without the Icon Fairbrother personnel that are on the page. And I'd just like to thank Alistair and WoodSolutions for the opportunity, along with you know, seeing Danny and Adam again. So thank you all.
Look, a fantastic job, and well done to all of you. You really covered it from every different aspect, just amazing. And I think a really important message you all sort of spoke about at the time, which would be sort of nice just to explore a little bit more, just how valuable that was the concept of early contractor involvement. And we talk about this a lot with timber buildings, you know, get your contractors in early so that you can, you know, talk through how it goes together. So Michael and Adam, you particularly spoke about that, but how did you sort of find that in a sort of day-to-day capacity? Were you sort of regularly meeting, and particularly early on with the timber suppliers, to make that successful?
Yeah, thanks, Alistair. I think Danny and Adam, we were probably on calls daily at the front end of the design, because everything was moving so quickly. We're basically you know, making sure design intent was met with Adam and his team. He could see the 3D modelling that Danny was seeing. Danny was obviously checking off with the fixings and obviously the timber tolerances that the GLT had to hit in the model. And look, you know, the structural engineers were there asking questions, and the fire engineers were also there looking at, you know, exposure to you know, steel and various fire rated elements. So it was basically a daily meeting with all parties concerned, just to make, I talked about the typical connections. I think we were pretty comfortable with all those typical connections, but it was the non-typical that really got us working over time as a team to flesh out and work through. Yep.
I love the comment you mentioned, Michael. Can you get your view, Adam, here about locking in the architect? But that is an important thing, isn't it? Particularly when with these types of designs, when you do that design up front, the whole thing you want to do is get it locked down and not make changes when you get on site. It really is different to a concrete building, isn't it? But I don't know how you felt about Adam about that comment, but I'm sure that was all very amicable and worked well.
I knew it was coming, but it's also it's fair and deserved, right? But also from our perspective, there's just never enough information on these. Like, we're also really we're kind of dying to know, well, what, how much can we adjust this angle, or how much can be this cantilever. So there's also from us a desire to have as much information as possible. And one of the challenges with this material is that it's new. The NCC is still catching up. Engineers are still learning. Regulators are still learning. There'll be a whole nother lecture around the fire engineering and the fire brigade and the CFA. Everyone's still kind of learning on the job, and everyone's asking questions. We all want things to settle down. So I think we're all kind of carrying this burden of innovation at the moment. But hopefully, we're all, I think, individually and as companies and practices, sort of learning through the projects, and then the next ones that come through, we're going to be even more capable of moving through these, faster and faster as we all learn.
Mm-hmm. That's a really important point, and there was sort of questions there around the extensive use of timber and how to deal with fire and spread of flame. And I think you guys have covered that. But you talked about still the need to do fire testing, which does surprise us. After so many buildings have been done, it is interesting the fire regulators still want more testing done. I mean, there's been thousands of buildings built around the world to show that they certainly perform well in fire. So we still need to do that with the regulators. But I was interested, Adam, you showed that detail about with the CLT soffits that a lot of them were exposed, but I think you also showed a detail where there was sort of fire check plaster used through the centre, which is an unusual detail. I haven't seen that before, where you can see the glue lam and see some CLT, but then some fire check in the centre. Was that just for fire or for acoustics as well?
It was a combination. So look, firstly, it had to be for fire. So the black art of fire engineering, what came out of it was that 50% of the CLT had to be fire protected. And we took that because it's great. We're going to get 50% visible. We've got to have an area that's protected with the standards for workplace design, especially in terms of acoustics. It allowed us to essentially achieve all of the acoustic performance to the space, doubling up a layer of acoustic material on that fire-rated plasterboard swatch on the ceiling. So yeah, it just served two purposes, and the fire and the acoustic stuff aligned quite nicely.
Yep. There's a question here, Michael, just on how many actual crew in the engine needed on the live deck for the installation. How many people did you have involved? Usually it isn't a lot with the timber structures.
Yeah, that's right, Alistair. There wasn't a lot. We had two crews for the CLT. I guess the floor plate was so vast that we saw efficiencies in sort of moving two crews once the beams and the columns were on for the floor. The CLT, I think, we sort of set off a point in the floor plate on either side, and we worked in towards the middle of that. The GLT, there was just a handful of people in the team there. When the truck came, we were basically just here's where you lift, here's where you put down, and that was really it. So it was a very minimal crew. Like you looked at when we were doing the concrete side of it, you had form workers, you had steel fixers, you had an army when we go for the pour, but a handful of individuals putting together the other side of the building was pretty amazing to see that happen. Yeah,
fantastic. Look, we're just about out of time. I noticed Stephen asked a quick question there about how he's loving the mass timber, but are we confident that today's young carpentry apprentices will be able to thrive here, particularly with sort of supply of timber? And just two things on that. I might just add, Look, supply was certainly an issue back in COVID. It was an issue for everyone, but there's certainly plenty of supply around at the moment, so don't be concerned about that. And look, with the young carpentry apprentices coming forward, this is really an area that there's a huge interest in the TAFE and the uni sector. And people may not be aware, but Box Hill has actually developed 2 courses which are now running nationally. There's a course in prefabricated timber installation. So if there are people that haven't done this before and they want trades to upskill, Box Hill provides that. And they also do an associate diploma, I think it is, in project management on prefabricated timber. So companies that have staff that want to actually train up can also do so. Look, gents, thanks once again today. It's been an absolutely fantastic presentation. You've covered off on everything there, and really sort of thank you on behalf of all the audience. I'd just like to remind everyone that the webinars are recorded. That question actually came up a couple of times in the chat. It'll be uploaded to the website probably over the next 3 or 4 days, but definitely in the next week. Also, our next webinar next month is on Tuesday, the 3rd of October at 11 a.m. and it's all on the Westgate Tunnel Engineering, and the presenters there from TTW that were sort of heavily involved in putting that project together. So a great project to tune into in a month's time. So thanks everyone for attending today. It's been great to have you part of the webinar, and we look forward to having you in our webinars in the future. Thanks once again, all the speakers.